All right, so this is going on page 43 when we're done. Now, this is not an all-inclusive review for this test. This is just a review of the limits part of it that kind of puts everything together. So it's a good reference sheet where, I mean, we did different types of limits in different sections in this unit, and it just kind of puts them all together to hopefully help you make sure you can keep them all straight. So when we are talking about limits and end behavior, okay, end behavior way out at the infinities where we can't see, that means we are talking about horizontal or slant asymptotes when we are talking about rationals. And remember, all of you that came from Archer, it's asymptote, not asymptote. God bless her. Asymptote. And I think that as far as limit notation is concerned, overall, y'all are doing a really good job of that. Those of you where it was kind of a hot mess for a while, you've pretty much cleaned that up. But I'm going to remind you one more time that this part down here is technically like a subscript and smaller. It's fine when you write it that it doesn't look that way. Just make sure that these two things are stacked. There's no line because it's not a fraction. And then the function is out kind of in front of that. Don't make it look like this little part here goes all the way underneath all of it, because that is something you have to actually write out on an FRQ on the AP exam. So if we can get this nailed down now, you won't even have to think about it anymore and we'll be fine. But knowing what the limit notation actually looks like and also knowing what it means, even though it says verbal, nobody's going to be saying it to you on a test, but it'll be written out. Sometimes you're asked for both ends. Sometimes you're asked for just one. And then some of you are still giving me both or the wrong one. And I don't know. I'm pretty confident it's because you're not reading the question, not because you don't understand what it's asking. I can help you with the understanding part. I can't help you if you choose not to read, because you're capable of reading. You choose not to read for whatever reason. But when it's the left end behavior, x is approaching negative infinity. Right end behavior, the limit is approaching infinity. I think we all get that, which way is which, as long as we know our left from our right. But it's not always going to say give the left end behavior. It may say things like, as the input, which is our x's, as the input values decrease without bound, getting smaller without bound, that means as x approaches negative infinity. Then the output values, blah, 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 whatever. Or as the input, which again is x, values increase without bound, that would be x approaching infinity. Right? So we got to know what it looks like in limit notation, what it looks like in words, so we can get it all correct, because the concept itself isn't difficult for you, I don't think. Then we look at this graphically. And here, we've got both ends as x approaches negative infinity. So when we're looking at this, as x approaches negative infinity, so as x gets smaller and smaller and smaller, the y values here are approaching what? 1. And as x approaches infinity, so as my x values get bigger and bigger and bigger, my y values are approaching what? 1. And that is because I have this here, because I have a horizontal asymptote at y equals 1. So when you have a horizontal asymptote, your end behavior, if it's approaching the infinities, the answer to that is the y value of the asymptote. It's the same for both ends. Okay, well, good on that? All right, so then here, for this one, for this f, as x is approaching negative infinity, so as x is getting smaller and smaller and smaller, the y values are approaching what? Negative infinity. Good. And as x approaches infinity, the y values are approaching infinity. Okay, so this is, here we have a slant asymptote, right? So on the quiz, because I know I had some questions about this after the fact, because some people put the equation for the slant asymptote, which I think might have been x for that one. So people were putting x. Yes, you're you're right, but you're not right. The function is approaching the line, but the value of that is approaching infinity. And so we're looking for an actual value there, not some sort of equation. So when you have a slant asymptote, so the reason this is true is because I have a slant asymptote. And for end behavior, I don't care what the actual equation is. Now, if I'm graphing it or if I'm straight up asked for the equation, then I got to find what the equation actually is. But when I'm talking in behavior, all I care about is what the slope of the asymptote is. And so this is true because I have a slant asymptote with a positive slope. So it looks like this, which tells me that's the end behavior of the function as well. So as I approach negative infinity, approaching a negative infinity, and so forth. So for a horizontal asymptote, the left and right sides are exactly the same all the time. If it is a slant asymptote, they are opposite because it's a line. It's going to have to be opposite. You just got to figure out which way the opposite is. Okay? We okay with that? Questions? Yes? Okay, so if the slant asymptote went the other way, if it went like this, right? So just pretend like it's flipped around the other way. You with me on that? Then as x approaches negative infinity, y is approaching infinity. And as x approaches infinity, y is approaching negative infinity would be opposite. Does that answer your question? Okay. And we're going to look at that again right here. That's why I hesitated for a minute. I was like, wait, I might kind of re-answer, but I'll kind of answer it again when we get here. Okay, no, you're good. Good question. All right, anything else? Okay. All right, so then when we look at these with the equations, so if the graph has a horizontal asymptote, which we just looked at with the graph, but let's say we don't have a graph, we just have the equations, then the y value of the horizontal asymptote is the limit. Right? So let's talk about why we get these asymptotes as well. So if I look at this first one, if I look at f here, that is that top heavy, bottom heavy, or tied in degree? Tied in degree, which means that the numerator and denominator grow at the same rate. So when I start putting in bigger and bigger numbers and they're getting closer and closer to infinity, this 1 and the -7 kind of become irrelevant, right? Because the numbers are so big. And even these two kind of become irrelevant. So, and they're almost growing at the exact same rate, just a little tiny difference that's irrelevant. That's why we look at just the ratio of the leading coefficients here, and we get y equals 2/5. And without looking at anything, I know that since the horizontal asymptote is at 2/5, then whether I'm going to negative infinity or infinity, my y value is approaching 2/5. Okay. When you look at g of x, top heavy, bottom heavy, or tied in degree? Bottom heavy. Okay, which means the denominator is growing at a faster rate. So let's think about a simple fraction like 1/2. And then if the denominator is growing, then it's 1/4, and 1/10, and 1/100th, and 1/1000th. So the bigger and the bigger the denominator gets, the smaller and smaller the number gets, right? So as x approaches infinity, that fraction gets tinier and tinier and tinier and gets closer and closer to 0. And that's why this y equals 0. Okay. And then since that is my horizontal asymptote, again, something we already knew, but now we just tie it to limits. That's what it's approaching, so these are both 0. Okay? All right, so then we get to, so that was a tied in degree and a bottom heavy, so we're going to get to a top heavy. If the degree of the numerator is greater than the degree of the denominator, then the left and right limits will be unbounded. So we're going to the infinities, not to a number. And specifically, you kind of have to know two things about it being top heavy. One is how you get a slant asymptote, and then some specifics about slants. And I've talked a few times about the other ones, like we could have a parabolic asymptote. You're not going to be given a graph or asked about an equation that actually asks you about it when it has that. You may just be asked, does it give you a slant asymptote or not? But we're going to at least talk about it a little bit more. But the end behavior will mirror the end behavior of this simplified ratio. So when we look at k of x, Is that top heavy, bottom heavy, or tied in degree? Top heavy. And it's top heavy by 1, so does it give you a slant asymptote? Yes, okay. If I wanted the actual slant asymptote, I could do long division. I don't need that for limits. Nobody's asking me specifically what the slant asymptote is, or I don't have to graph it. But I do need to know something about it. So I look at the two leading terms. I make a ratio out of that, so x cubed over 2x squared. So that means my slant asymptote, well, when I reduce that, I will get 1/2 x. That is an equation of a line. It is not the equation of the slant asymptote, but my slant asymptote is parallel to it, right? All that would change would be the y-intercept. So since it's parallel to this, and this has a positive slope, I know that the slant asymptote looks like this. Where? I don't know, but it's not on a grid anyway. So what this tells me is that as x approaches negative infinity, if I'm going to the left, y is getting smaller and smaller and smaller, also approaching negative infinity. And as x gets bigger, y is approaching infinity. And if I had gotten if that was a negative 1/2, then the line would be flipped around the other way, and these two would change places. Okay? Does that kind of help answer your question also? Okay. Any other questions? All right. So then when we look at r of x, it is top heavy. Is it top heavy by 1? No. So do I get a slant asymptote? No. So that's really the extent of, so I wouldn't have a slant or a horizontal, right? That's really the extent of what you absolutely have to know. But we always talk a little bit more about than what we necessarily have to know. It's still, what it says here is it's top heavy. So I'll still take this ratio, right? So then this would give me negative 3x to the 5th over x cubed. So then I get y equals negative 3x squared. Okay, clearly not a line, right? So I would have a parabolic asymptote. Nobody expects you to be experts on that, just telling you that at this point. But the end behavior would mirror this end behavior. That's not the exact parabola, but it gives me the end behavior and what's going to have to happen. Since this is a polynomial, coefficient's negative, the right side would be down. Since it's an even degree, the left side would be the same. So that means whatever's happening here, and you don't have to know anything else about it, but the end behavior, they're both going to be approaching negative infinity. Okay? What questions you got? We all good so far? Yes, ma'am. This one? Okay, tell me where did I lose you? How I got this? Or how I got this? Okay. So do you understand that this is just an equation of a simple line? Since it is a positive slope, my line has to lean like this. Okay? You okay with that? All right. So if this was on a coordinate plane, whatever's happening, right? And let me actually extend my line a little bit longer. Then my end behavior here, so my graph would look something like that. It's got to be approaching this line, I don't know, something like that. So even though you don't know anything about what I did in purple, because the green line you know has a positive slope, as x approaches negative infinity, as x gets smaller and smaller and smaller, since the function will be approaching this line, it's heading towards negative infinity, just like what this is pointing at. And then when x gets bigger and bigger and bigger, then since this is approaching this line, the only thing that can be happening is that y is going to positive infinity. Does that help? Okay, good. Thank you for asking and asking again. What else we got? Anything else? I'm sure you're not the only one questioning it, but you're the only one willing to speak up. All right. If I need to come back to it again, I can do that too. All right, so now that was all end behavior, right? We are looking at limits and vertical asymptotes. So this is really more like middle behavior, which is not technically a thing, but I think it should be. If we have end behavior, it only stands to reason we'd have middle behavior, which means we're not talking about the infinities. We're talking about the stuff we can actually see for the most part. Okay, so with vertical asymptotes, we look at limits from both sides. We can't get to the other side of infinity, right? We can only approach infinity from the left. We can't approach infinity from the right, because if you can't find the end, you can't get on the other side. But when you have a vertical asymptote, you can come from both sides of it. So it's different than looking at end behavior. So with vertical asymptotes, you're only looking at the immediate left and right side, meaning what's in its little neighborhood. We don't care what's happening out in the suburbs, just right there in that little neighborhood there, to see if it's unbounded. And if you have a vertical asymptote, then you're going to the infinities no matter what. You're either going to positive or negative on either side of it. You've just got to figure out which way to go. So one way I know it's not in behavior is because it doesn't say that I'm approaching infinity. If I'm approaching a number with a rational for what you are doing right now, so this is not an always statement, but always for us right now. If you're approaching a number, we're going to be talking about a vertical asymptote or a whole, okay? So as I approach 2 from the left, I can clearly see I have a vertical asymptote at 2, right? So when I come in from the left, the y values are approaching infinity. And as I approach 2 from the right, the y values are approaching negative infinity. Okay. And graphically, I think we do okay on that. Graphically, I think the reason I get weird answers sometimes is because you're not paying attention to what this says, and you're assuming it's in behavior, so you're trying to do something else weird, okay? What questions we got right now? We're good so far? Okay, and then this is it verbally, basically what I just said. But again, if it says it and you have to write it, make sure you know what the notation is with the little plus and minus up where an exponent goes. Okay, so then equations. When you were talking for equations, when you don't have something to look at, you create a sign chart. And this is when you're talking about vertical asymptotes. So this was a question I got after this quiz where we did limits with vertical asymptotes and wholes. Like, how do I know when to do a sign chart? How do I know when I just look for a value like we'll do in just a minute? Well, if you know you have a vertical asymptote, your only options are positive and negative infinity. So what you all you care about is what is the sign? Is it positive or negative? If you're concerned with a sign, that's when you do a sign chart, okay? Now, when do you do the entire sign chart and when do you not have to? If this was a question that said, give me the intervals where h of x is greater than or equal to 0, something like that, then I would have to do the entire sign chart, look for all my intervals, and answer my question. Here, I don't care about the entire sign chart. I only care about the left and right side of the vertical asymptote. However, I still put all my information, I still put the hash marks where they need to be. And here's why. Where's my vertical asymptote here for h of x? 1. So it's at x equals 1, right? So I know 1 has to go on here, but I also need to put my zeros. So I have a 0, I have 2 zeros, and I have an asymptote. So I have a 0 at negative 4, and then an asymptote at 1, and a 0 at 3. Now, if, again, this was a question where it said, what are the intervals where h of x is greater than or equal to 0, or whatever, my asymptote would always have an open circle. Whether or not these were open circles would depend on whether it was greater than or equal to or whatever. And totally irrelevant here because that's not what it's asking, just reminding you of the differences here. It may even help when it's an asymptote for you to literally put an asymptote on there. I mean, I usually do that just because it makes a little bit more sense to me. Now, again, I'm not having to do the entire thing, but I need these numbers here, so basically I know where my neighborhood ends. If I was doing the whole sign chart and I needed something to the left of negative 4, I really should choose something close, but I could choose negative 500 and still be fine. If I didn't put this here and I wanted something to the left of 1 and I did negative 500, that would be bad because I can't go from the other side of this. You with me? That's why we put them there, so we just know what to choose. So I need to choose a number just between negative 4 and 1. I think I'm going to go with 0 because that makes everything easier. Now, this right here, if that was positive, I could ignore it. There's no variable on it. It does not give me a 0. However, it's a negative sign in that equation that doesn't change when I substitute stuff in, right? So I got to take that one into account. That's negative no matter what. I put 0 in here. 0 minus 3 is negative. 0 plus 4 is positive. no matter what I put in the denominator, I'm going to square it so the denominator is positive all the time, no matter what. So multiply all that together, and I get positive overall. Which means as I come in from the left, as x approaches 1 from the left, I'm heading towards positive infinity. So that first one is positive infinity. Does that by itself tell me anything about the other one? No, because it could be the same, it could be different, right? So then I do the same thing here. Between 1 and 3, I'll choose 2. This guy's negative, no matter what. And then 2 minus 3 is negative. 2 plus 4 is positive. Denominator's positive no matter what. That is positive overall. Which means that it looks like this. Looks like this on either side of my asymptote. So this one is also infinity. These could be the same, they could be different. Because we're trying to figure out what the sign of the answer is, okay? And so if I don't include this, and I just did these, which would make it negative, right? I still, to get my y value, I still have to multiply it by a -2. So that negative still affects it no matter what. It just doesn't change based on what I put in. So usually we kind of, like if it's positive, you can ignore it because the positive doesn't change anything. So I guess good practice would be, if it was positive, we'd start with a positive sign, but we just kind of don't need to. Okay, good question. What else we got? Anything else? All right. Everybody good with vertical asymptotes? Visually, I think you're good. You have to do a part of a sign chart if you have an equation. So then we get to limits and holes, which is, again, is more middle behavior. Okay? We don't care about what's happening at the end. So in this graph, I still have a horizontal asymptote and a vertical asymptote. And I also have a hole. How do I know what I'm looking at? Because I look at what this says. As I'm approaching 2 from the left. Well, my vertical asymptote, oh, that's my vertical asymptote's at 1, so that's not what we're talking about. Horizontal asymptote, we'd be talking about infinity. That's how I know to ignore all that. As x approaches 2 from the left, y is approaching that hole. As x approaches 2 from the right, the y value is approaching that hole. This is a very good example of us both heading towards the kitchen and the refrigerator's gone, right? We're coming from different rooms in the house, but the refrigerator's gone. That type of thing. When that happens, I don't need to do a sign chart. All I need is the y value of that hole. My y value is approaching whatever that y value is, which happens to be 2. Which I wish now I had changed because the x value is 2, and I can see how that can be confusing. But this is the y value here. So let's add a little note in here. If we have hole at x equals c. C just being some number. That's C's used a lot. Just any random number. I'm not going to use a number sign because it looks like a hashtag, and then we're not going to go there. Then the limit is equal to the y value. That's all it is. So if it's a graph, I should be able to pull that number right off the graph. It should be a y value you can pull off the graph, not a tricky thing. Melvin, you with me? Hard to pay attention when you're asleep. Sit up. And then the verbal is kind of the same thing there. Right? We all good with that? Yes? Sit up. All right, so then what if I have an equation and I don't have that to look at? So for equations, we can find the limit value at a hole by plugging the x value back in after we've canceled out the common factor. So when you are given an equation like this, I think we all are pretty confident we get this. We can cancel that out. We get a hole at x equals 3. Okay. I also have a horizontal asymptote at y equals 1 and a vertical asymptote at x equals 1. Given that they're asking me this, I don't care about either one of those things. That's how I know I'm referring to the hole, right? Fernando, you with us? Sit up. my wake her up. Sit all the way up, 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 up. All right, so if that happens, then we have canceled that out. Our reduced function is x plus 5 over x minus 1. So then for me to find this limit, no sign chart, okay, I'm going to do k of 3 with my reduced one, and I get 3 plus 5 over 3 minus 1, 8 over 2, which is 4. So if I have a hole, my left and right limit, they're going to have to be the same because we're heading to the same spot. Okay? What questions do you have? Okay, so that's kind of all the limits with rationals all wrapped into one so you can see how they're the same and how they're different. I'm going to give you another sheet of paper that has always, sometimes, never questions on it. And we're going to go through this as well. I'm going to give you a little bit of time, about a minute for each one we talk about, for you to read over it and maybe talk about it together real quick. I would give you more time, but I want to make sure I have time to actually talk about them. Mm-hmm. Yes. So for each question, there are 3 statements. So we're going to start with number 1. And you are going to look at that. We've just got a function that is, it's 1239. A function, here, let me get over here real quick. There we go. So you know that you have a rational function is just a ratio of 2 polynomial functions. They're talked about separately, so I'm going to give you about a minute. I want you to read through that. See if you can figure out which one would be always, which one would be sometimes, which one will be never. And you can talk about it amongst yourselves if there's enough time. You can sketch yourself a little picture. You can write stuff out, like whatever you need to make it make sense to you, whatever works. Okay, I know that's not enough time, but again, if I don't stop you, we're not going to have time to talk through them all. Okay, so we have a rational function. It's a ratio of 2 polynomials. So this says if h of x equals 0, that means the denominator. When x equals 3, then f of x has a vertical asymptote. So we have to decide if that's always, sometimes, or never true. So here's what I would do. Here, like an equation type thing might help me. When it says h of x equals 0 and x equals 3, that would mean I would have to have an x minus 3 in the denominator. Okay? So do we all understand how the first part of that sentence means this? All right. So then it says, then f of x has a vertical asymptote at x equals 3. Okay, so here's how I want to think through this. Could this mean that I definitely have a vertical asymptote there? Absolutely. Is there a time where this would still be there, but something else might also be true, where I then wouldn't have a vertical asymptote at x equals 3? What would have to happen then? That would have to cancel out, yes. Which means if I have this, then I cancel out and get a hole, and then I don't, right? So it's possible if the first part of that is true, and I don't have one in the numerator, then I would. If I do have one in the numerator, then I wouldn't. So do you think this is always, sometimes, or never? Sometimes, okay? Just depends on what else is happening. All right, so then the second part says, as the limit as x approaches infinity, is 3. So f of x has a horizontal asymptote at y equals 3. All right, well, if x is approaching infinity, and I don't know from the top or the bottom what's happening here, but as x gets bigger and bigger and bigger, if my y is approaching a positive 3, I would have to have a horizontal asymptote right there, right? Otherwise, it doesn't stop it. So I'm thinking this is always. Does that make sense to you? Now, and I know somebody's going to ask me this question today. Are there going to be always, sometimes, never questions on the test tomorrow? You know what? It doesn't matter because y'all focus on the wrong things sometimes. Like how many questions are on the test? What difference does it make? 45 minutes worth, okay? So are these kind of questions on the test? It doesn't matter. If we can answer them now, then you understand what you're doing and you can answer other questions. You with me? So just think about it that way. All right, so then this says the limit as x approaches 3 of g of x is equal to infinity. And then f of x would have a 0 at x equals 3. So let's just take care of the first part. As x is approaching 3, and that would mean from both directions, the function is approaching infinity. So if I make this 3 right there, so as I'm approaching 3, I'd have to be approaching infinity. Could I have a 0 here? What would have to be at 3? A vertical asymptote. Can you have a vertical asymptote and a 0 at the same spot? No, you cannot. So this would definitely be the never. Okay? We see how that works? All right. So next one, the function looks the same. So read through these. Again, I'm only going to give you about a minute because that's all the time I have to give you. But it's better than nothing. You can at least try to think through it before we talk about it. And you can talk about it amongst yourselves too. Okay, so let's see what this says. The first statement says g of 2, if g of 2 equals 0, okay, g is the numerator, and if g of 2 equals 0, that means I would have to have an x minus 2 in the numerator. That's what the first part of that statement says. It says, then f of x has a 0 at x equals 2. So is it possible that if I have that, that I would have a 0 at 2? Yes. Is there another situation that it could occur which means I don't have a 0? Yes. If I have this, then I could have a hole, right? So it just depends, and they didn't tell us anything about h, so this would be a sometimes, because it could work either way, right? Okay, so then the second statement, h of 2 equals 0, that's the denominator, so that's an x minus 2. If that is true, then f of x has a 0 at x equals 2. Well, if that's the only place I have an x minus 2, that would mean that I have a vertical asymptote there, and I know I can't have a vertical asymptote and a 0 at the same time, right? If I have this, that means I have a hole, right? I could also have this situation. If I have this situation, then I can cancel this out with one of these. Still looks like I should have a 0 there, right? But I canceled it, I had a hole. When it's a hole and a 0, which one wins? The hole. Very good. I would have the hole like on the axis, but I'd still have a hole. So remember, vertical asymptote wins out over hole, hole wins out over 0, so this would be a never. Okay. Then g of 2 equals 0, so that's the numerator. So I'd have an x minus 2 up here. And h of 2 cannot equal 0, which means for sure I do not have one of those in the denominator. If I for sure don't have one in the denominator, then I have a 0 and nothing else could happen, right? We go with that? The different things that could happen. All right, good. That's an always. All right. You got 1 minute to look at number 3. Think about it a minute and see how you would think about it. All right. So if you look at how I thought through some of these up here, some of them with the asymptotes that was kind of graphically made more sense, just some little picture, and sometimes just setting up a little equation makes a little bit more sense. If I have transformations, which I do here, and I don't know exactly what my equation is, like I know where these asymptotes are, so I kind of know how to build one, but I wouldn't know everything I needed to know, then to me, and I mean, everybody thinks about things a little bit differently, I prefer to look at this as much graphically as I can, because then I can think about how things are moving around. So here it tells me that I have a vertical asymptote at x equals -2 and a horizontal asymptote at y equals -2. Okay, so that's what I know for k. And then I understand how transformations work. And I don't care about anything else in the graph right now. The asymptotes give me a lot of information. Where my vertical asymptote is only affected by any x transformation. And then the horizontal one is affected by the y transformations. So when I look up here, there's only one x transformation, right? And this says, m of x has a vertical asymptote at x equals -5. Well, this means I translate which direction? Left. So if I'm here at x equals -2, and I go to the left 3, then I have a vertical asymptote at x equals -5, and that's the only thing that could happen. Does that make sense to you? So I think that is always. And to me, that's way easier than trying to reason through an equation that I'm not sure of, or what. Just think about graphically what it looks like. That's why it's good for us to know all the different ways to look at things. So then the next one says, m of x would have a horizontal asymptote at y equals 5. We currently have one at -2. This does mean that I go up 7. So if I'm at y equals -2 and I go up 7, then I would end up at 5. But is that the only thing that affects y? It's not. It's not even the first thing I would do. The first thing is this reflection in the x-axis. So if I'm here, I would reflect in the x-axis and end up at y equals 2. Then I have a vertical dilation by 2, so it would actually move it up to 4. Then I would go up 7, and I would end up way up there at 11, not anywhere near 5. You with me on that once you think through all the transformations? So this is a never. And then m of x has a 0 at x equals -2. Well, k cannot, because there's a vertical asymptote there, right? There's a vertical asymptote there. But once I move that over, I don't know anything else about what's going on in the graph. That's definitely possible, so that would be a sometimes. Okay? We okay with that? All right, we're just going to talk through 4 together, because I can get that done in the next 2 minutes. First of all, this is written with that 4 up front, which freaked some of y'all out on one of the assignments that you had that wasn't even rationals. I can rewrite this as q of x equals -p times x plus h plus 4 and put it in the order that probably makes a little bit more sense to you. It's the same thing. 4 is still just a vertical shift. All right, so, and the picture's already there for me. That's good. It says q of x has a horizontal asymptote at y equals 7. All right, well, I'm down here at -3. The transformations that affect y. This is a reflection in the x-axis, so I would reflect up here to +3. Then I would move up 4, and end up at 7. So I think that one, that's exactly what's going to happen. So that's an always. This says vertical asymptote at x equals negative h. Negative h would mean that I've got, well, if I have this, I'm going to move to the left h. I'm starting at negative 1. If I start at negative 1 and move to the left h units, is it possible for me to end at negative h? No, because I started at negative 1, right? I can't get there, so this is a never. Does that make sense? That's why that's not possible at all. Then the 0. Right now I have a 0 at negative 1. I really don't know if I'm moving left or right. I could move in either direction, so I could definitely move to the right, and this would be a sometimes. Okay? What questions do you have? All right. Don't be afraid to sketch little things out, write little things down, try to wrap your mind around it. You can do well on this test if you come prepared. All righty?